Ladies and gentlemen, look at this wonderful exercise. We have to find the area of the watermelon. The area of the watermelon is approximately 176.7 square units. Impressive. Let's prove it. What are we going to do? Look, here we have like a bowl where the watermelon is placed. We know that in a watermelon, there's a quarter circle of watermelon. Alright, now what we're going to do is complete the rectangle. Look, we are going to draw a line upward, a line this way, and a line downwards, completing a right angle, right? There will also be 90 degrees here and also 90 degrees here. Perfect. Now let's draw a line from the top of the watermelon downwards.
Completely vertical line.
And it's going to be parallel to this line and this line here. And notice that we are going to call R the radius of the watermelon. From here to here, well, it is the radius of the watermelon. And from here to here, it's also the radius, right? And notice that this here is also the radius because it starts from the center up to this point, which is a tangential point between the watermelon and this side of the rectangle. Okay, so this good. Over here is also going to be fantastic. Now pay close attention that this line, because it is parallel to this one, will also measure R. So if this little piece from here to here is 6, then
is everything R.
So this piece here is going to be R minus 6. Very well, the same with this diet, everything measures R. And since this little piece from here to here measures 3, then this here should measure R minus 3. Great. Alright, so what's next? We're going to add angles. Let's call this angle alpha and this one beta. And check that when we're putting alpha and beta and not, we're saying that alpha plus 90 plus beta is, which is, ladies and gentlemen, 180 degrees, because the internal angles of a triangle sum up to 180 degrees. And look over here, I have beta and 90. That is to say, I have these two. And this angle here is a straight angle, right? So it's 180 degrees. How much is left then if I have beta and 90 degrees? Well, we're missing angle alpha. This angle here has to be alpha. Since this is alpha and this is 90, the third angle of this right triangle must also be equal to the third angle of this triangle too. Here, this angle will be called B. Magnificent. Now we can say that this here is R minus 3 and this here is R minus 6. And you might be wondering why. Well, because these are similar triangles, and we're going to explain that too. Look, let's call this side of this right triangle there. Let's call them. Alright, and we are going to relate the hypotenuse of this triangle with these sides here, the angle that joins 90 degrees with 20. Then let's say that R is to X. Let's put it here. Like who? Let's look at the other triangle, then the hypotenuse is R. It's here, let's see. The side that connects 90 with beta was X. Here 90 with beta is R minus 6. Alright, R6. We move this R6 to the other side. We have R6 left and we move this X over here multiplied by R, right? We missed the R from here. Very good. And this is going to be equal to X to the power X to the power. Dividing both sides by R. R over here and R over there. Now here, what do we have? We have that X equals R6 as we said before. So we had said that this was going to be R6. Therefore, the same happens with this triangle here. I know you can do this and find that this will be R3. Perfect.
Yes,
we have a right triangle and we have all its sides. So we are going to use the mighty Pythagorean theorem, and we'll say the sum of the two sides squared, that is this squared, R minus 3 squared, the other side which is R6. Alright, squared. It must be equal to the hypotenuse squared, which is R, so we have R squared. Fantastic, very good. Let's expand these binomials. R, the first term squared would be R squared minus the double point times the first by the second would be 6R, and the second term squared would be 9. Plus the first term squared would be R squared minus the double product of the first by the second 12 power and plus the second term squared would be 36. And this is going to be equal to r squared. And look at this marvel, we have r squared here and r squared there. Goodbye r squared. Let's leave the term r squared first, r squared. Then the terms that have r would be at 12 powers. Minus 6r minus 8r. Alright, here we have 9 plus 36, which gives us 46. And this is going to be equal to 0. Ladies and gentlemen, we have a quadratic function that we can solve with the general formula, or also factoring, right? So we're going to factor. This here is a trinomial, for those who don't know, in the form x squared plus bx plus c, and it is solved by opening two parentheses and taking the square root of r squared, which is r. We put it in both parentheses. This sign goes here, and the multiplication of these two signs goes there. Minus times plus gives me minus. We need two numbers that multiplied give me 45. And that when added or subtracted, they give me minus 18. Those numbers are 3 and 15. Look, negative 3 times negative 15 plus 45. And negative 3 plus negative 15 minus 18, perfect. We can set these two factors to 0. We can say that r13 is equal to 0. And that r15 is also equal to 0. Solving for r, we find that r equals 3 over here. And here r is equal to 15. Magnificent. But these two solutions to work for our quadratic equation, but not for the watermelon, right? So, what then would be the radius of this watermelon? Look, if we wanted to replace these 3 here, we'd get 3 minus 6, which gives us minus 3, and one side can't be negative, so it's just itself. They are useless for our exercise. The solution is that the radius of the watermelon is 15. Great, let's go find...
So would extract the area of
so
the
we have
sun.
that the area of the watermelon is going to be pi times radius squared over 4y over 4. Because we are talking about this being a quarter circle, since here we have 90 degrees. Very well. So we can say that the area of the watermelon is pi. And the radius would be 15 squared over 4. And that gives us, ladies and gentlemen, that the area of the watermelon is equal to 225,000 hectares. Subscribe. Square units, and this, ladies and gentlemen, is the exact solution to our exercise. There are 225 quarters of Santiago Street, alright, in square units of watermelon. And if we put this into the calculator, we'll find that the area of the watermelon is approximately 176.7 square units of watermelon. Let me know in the comments if you liked the video, and don't forget to subscribe and give it a like so you don't miss the next challenge. We will see each other another time. Bye.